Jonas Bease. I'm a bioinformatician at the Bioimage Archive, and I was really excited to hear earlier questions about data because that's what I'm going to talk about. I'm going to talk about everything AI4Life has been doing regarding AI data. So Sadeep, if you are still around, hopefully this will answer some questions, but if not, please feel free to ask at the end. So as we mentioned before, AI datasets tend to be composed of images and annotations, which are the expected output for a given task. And together, images and annotations are used to train AI models. And once the models have been trained, they can be deployed to analyze new images and we can gain new insights. But despite how important these annotated datasets are for not only training the models, but also to validate them, to benchmark them, and to be able to reproduce the results, AI scientists come across a lot of problems when it comes to data. These datasets are in many cases difficult to find because they get published in different repositories, so you need to kind of keep track where the good datasets are. Also, they get published in lots of different formats, both for the images and the annotations. So sometimes it's hard to even read an image in your pipeline. And finally, some of these data sets get published with very variable metadata. So the metadata is all the information that we need to be able to understand these data sets. And sometimes an AI scientist won't even know, I don't know, what license the data are under. So they cannot really reuse the data. So one of the aspects that AI4Life wanted to address was how we can standardize these AI datasets so we can share them and reuse them in a better way. And that's how the Bioimage Archive came into play in AI4Life. We are EMBL-EBI data resource for biological images, and we store and serve biological images from multiple modalities, as I hope you can appreciate from this slide. But we don't only accept submissions of biological images, but also of their annotations, such as segmentation masks, point annotations, bounding boxes, anything really. So you could submit to the archive just images with their corresponding annotations, or only annotations for a pre-existing submission of images. And what we want to do with the Bioimage Archive is to enable the reproducibility of published scientific results. So most of our submissions are related to scientific publications, but not all of them, because we also serve some datasets that are particularly useful for different communities. For example, cell atlases or benchmarking datasets. And finally, what we want to really empower is the reuse of biological images and annotations. So of course, we can reanalyze images, we can gain new scientific insights, but these images can also be used to develop new image analysis methods. And of course, that includes AI methods. But to be able to share those datasets in a fair manner, which is a concept that already Anna has introduced, and FAIR stands for findable, accessible, interoperable, and reusable, we need to have standards for both the data, so the images and the annotations in our case, and the metadata. So let's start with the metadata. When AI4Life started, there was already relatively well-known standard for metadata of biological images called REMBI. REMBI was created by the community in 2021, and it has different modules that include information, for example, about what we have been imaging, so what organism, cell line, what tissue, or how we perform the imaging, so what tool you use, what parameters you use for acquisition, etc. But in AI4Life, we realized that there was not a standard for the annotations. And as we mentioned before, annotations are very important for these AI datasets. So if we need to reuse these datasets, we need to have a standard for annotations as well. So at the beginning of 2023, we organized a community workshop with different experts, and we came up with what we call the MIFA standard for annotations. And this standard, as you can see, also has several modules represented here in circles. These modules include information, for example, about who are the annotators of the dataset. We thought collectively that it's very important to recognize the people that annotate datasets because it's very hard work that often is done manually by experts. And there are other modules, for example, to we need to say what type of annotation we have produced, right? A segmentation mask, tracks, counts, etc. And then we have another module here called method, which is all about explaining how we created the annotations. So were the annotations created manually, were they created using software, were they created by experts or crowdsourced, etc. And then we have a bunch of other modules that try to also relate the annotations to the original images from which they were derived. So both REMBI and MIFA have now been implemented into the bioimage archive, and our users can use our user-friendly web tool to submit all of the information that we need to be able to reuse these annotated datasets. And in fact, our users do submit many of these type of datasets with all of the information, not only for images, but also for annotations. So now if a scientist submits a dataset to the bioimage archive with annotations, the dataset is going to be findable because we are a centralized repository. We do things like assigning unique identifiers like accession numbers or DOIs. The repository is searchable. The data is going to be accessible. We only allow permissive and open licenses, so people can reuse the data, but also you can download the data using a variety of different methods. And the data is reusable. Again, we have open licenses, but also we have all of the metadata that we discussed earlier, so people can really understand how this data was created. But as part of AI4Life, we wanted to be able to serve AI researchers better because they are the actual consumers of these AI datasets. So we consulted with the community and we came up with our AI galleries, which you can find in our website. And inside the gallery, you will be able to do different things that are related to AI data. The first thing you can do is to explore our AI-ready datasets. This is a collection of annotated datasets that we curated particularly for AI scientists. So if you click in one of these datasets, you will be able to see first how an image and an annotation for this dataset looks like. And then the metadata that you will find here is not the usual metadata that we have in our study pages. It has been pared down and catered towards these scientists, AI scientists. So you will find, for example, what type of annotations are included in this dataset or what type of imaging was performed. But the most important feature is that if you click on the images, now you can also view them, which allows AI scientists to be able to explore these datasets before they decide if they want to download them for their purposes or not. And we achieve this by converting these images to an open and cloud-ready format called OMSR, which allows us to stream these images. You can see that here I'm zooming in and out the image and going through different time points in this time lapse. So I could really get a good sense of the images. And I could even copy the link to this image to include it in any cloud-based analysis that I have. So by converting our images to OMSR, now we have made them interoperable because they are in a single format. And by curating the metadata, now these datasets are particularly useful for AI researchers. But in AI4Life, we start thinking that if we have interoperable data and we have interoperable models, like the models in the bioimage model zoo, we can start integrating both. And we started creating what we call our model comparison platform. So those are the two other options that you can access in our gallery. And the idea behind both is the same. We have a bunch of models from the bioimage model zoo and a bunch of datasets from the bioimage archive, and we deploy the models on the datasets. But the views are slightly different. This one here is a data-centric view. So here, what you're going to see is for a given dataset, how different models perform. So the idea here is that if we have a scientist that wants to start using AI methods from the bioimage model zoo, but they don't know where to start, they can look at datasets that look a little bit like their own data and see how different models perform and which model could be better for themselves. And this other view is the model-centric view. So here what you will see is for a given model, how it performs perform on different data sets. So this is more for model developers that submitted to the bioimage model zoo, and they want to see how their model performs in a variety of data. So they can see, for example, if their model is suitable for transfer learning. So let's start with the model-centric view. Here, what you will see is different models from the bioimage model zoo, with a little bit of metadata in each card, just so you know, for example, what task the model was developed for. If you click in one of the models, you will see a representative image. So immediately here we can guess that this model does segmentation of cell nuclei, but of course we have metadata that tell us that that's what the model actually does. And this model was used in a bunch of different data sets from the archive. You can see different data sets in each row in here. And because these data sets had ground truth annotations, we could compute different metrics for benchmarking segmentation. So you could explore for what type of data set this model did better. Of course, you probably want to be able to also see the outputs from the model. So that's what we have in this other table here. For each one of the datasets, we have the original image, the reference annotation or ground truth, and here you can see the outputs from the model. So you can really have a visual kind of idea of how the model was performing. Now, if we look at the data-centric view, what you will see is a dataset, and for the dataset, an image and an annotation is relevant. In this case, for example, the annotation method is really important. And because this model has also ground truth, we can look at benchmarking metrics. In this case, in each row, you will see a different model, and we can look at what model did a better job in this specific dataset. And importantly, we can also look at the outputs from the models here. Once again, we can look at how the models perform. So just to summarize, what I show you today is that in the context of AI4Life, we have done a variety of different things regarding data. First, we came up with the MIFA guidelines. And these guidelines actually go beyond metadata. They are also, we gave some advice regarding formats, regarding data accessibility, incentives for scientists to produce this type of data. And this is going to be published soon in Nature Methods. So if you are interested, you can read the paper hopefully soon. I also show you our AI-ready datasets, which are geared towards AI scientists that want to use this type of data. And finally, the benchmarking platform, which is catered to both model consumers and model producers. And with that, I want to thank everybody from the AI4Life consortium, because this was a collaborative effort. Of course, everybody that participated to create the MIFA guidelines. I saw some of you, Vladimir, and others in the audience today. And of course, the Bioimage Archive team, which is led by Matthew Harley, and pretty much everybody from the team collaborated in creating what I showed you today.